Alright, so in this video we'll try to talk about the resolution of vectors. Now, so far we know what the resultant of two vectors would be. If this is our A vector, say 4 units in the east direction, A vector, and this be our B vector, say 3 units in the northeast direction, then we know that the resultant would start from the base of A to the head of B, something like this. This would be the resultant vector R, which would be A plus B. So this would be our resultant vector. Now, we want to ask ourselves if we can go backwards. That means if we have our vector, like so, and we want it to be resolved in A and B. But in more general terms, we want it to be resolved in the form of this. So we want R to be of the form lambda times A plus gamma times B. Now, from our discussion in our previous videos, we know that if A points in the east direction, then gamma A is another vector which should also point in the east direction, as long as gamma is positive. Now, even if that's not the case, it will still point along the horizontal direction. So gamma A would be parallel to A. Lambda A would be parallel to A. So if lambda is positive, so case 1 is if lambda is positive, then lambda A would be pointing in this direction. And if lambda is negative, then lambda A would be pointing in this direction of some other length. So these are two conditions, but even if those conditions are not matched, we know that lambda A, even when lambda is positive or negative, in both the cases, would still be pointing in a horizontal direction, so east-west direction. So that is something that we want in mind. But let's not get into the intricacies of this discussion. Right now, we'll save that for later. So we know that since A points in the east direction, lambda A would also point in the east direction, and same thing with B. So if B points in our northeast direction, as here, then gamma B would also point in the northeast direction, or in the southwest direction, because we want it to be along this line, and we want east and west to be along this line. So both the directions should be matched. But for understanding this in more simpler terms, let us assume that lambda and gamma are both positive for the moment, even though the negatives are also possible. Right, so with that in mind, we want to ask ourselves if this is possible. So if we're looking for lambda, we're basically looking for this vector lambda A. And this is a composite vector. We want to look for A prime and B prime, where B prime is gamma times B and A prime is lambda times A. Now, both of these would be parallel to A and B, respectively. Therefore, if we want to draw them out, say for A, and A must be drawn from the base of R. Therefore, A prime should also begin at the base of R in the direction of A. So let's draw an infinite line in the same direction as defined by vector A. And for B, let's do the same thing, but in the direction of B, and also from the head of R, because B coincides with the head of R. So we want our B to be in this direction. Now, knowing that the intersection of these two lines give rise to this length here, this must be A prime, and this must be B prime vector. So this means that we have resolved R in the direction of A and B. If we take some other vector, let's take another vector of pointing in, say, this direction. Here, this direction. Let this be a vector T. Now we want to resolve T as a form of T equals some constant. So let's take that constant to be alpha times A vector plus beta times B vector. So we want this to be of this form. Now if we want this to be of this form, we know that both the decompositions should be parallel to A, and this would be parallel to B. We do the same thing back again. Now, from the base, we draw a line, an infinite line, in the same direction as A, this vector here, and from the head, we draw the line, an infinite line, parallel to the second decomposition vector, so that's B. So B is in this direction. I'll do my best to draw it parallel to that. It seems as though this might be good. So that intersection gives us two vectors, and from the diagram we can figure out what the two vectors would be. So this length here, this vector pointing in this direction, from the base to the intersection, would be alpha times A, and this vector here would be beta times B. Now, from the diagram you can see that, wait, A was pointing in the east direction, but alpha A is pointing in the west direction. Why is that? And is that still okay? Well, it's okay as long as both of them point in the east-west direction. And if A is pointing in the east direction and alpha A points in the west direction, then that's a clear indication that alpha is a negative number. So that is to say that a vector could be resolved as a combination of two vectors with any constants multiplied to it. So T could be of the form some negative number times A. Let's have that as minus 2 times A, plus some positive number times B, because beta B is still pointing in the same direction as B, so beta could be positive. It could be something like this, 3 times B. So T has therefore been resolved in these two vectors here. So this is what we mean by resolution of vectors. Now, it takes a bit more mathematics to prove that you can only have one resolution of a particular vector. That means if you have this vector T here, you cannot have any other combination of A and B. So if T were minus 2A plus 3B, where A and B are the vectors over which we're resolving T, then you could not have the same T vector to be some other linear combination of A and B. That is to say, it could not be minus A plus, say, 5B. This could not be possible if this were true. So if this were true, then this has to be false, or the other way around. If this were true, then the first statement would have to be false. That is, you can only have one decomposition. So that it takes a bit of, it's a bit more involved to prove that. But we'll ignore that for the moment. We'll assume that there's a uniqueness sort of predefined in this scenario, and we try to work with that. So we can only have one decomposition. So this decomposition or resolution, as two words I've been using interchangeably, is what we intended to do with a given vector. So now that we know that T could be resolved in terms of A and B, in some linear combination of that, linear combination because we're just adding these two vectors, and linear because we're multiplying it by constants. So with that in mind, this is one type of linear combination of T. Now we could have any other vector, say vector V, and that could as well be resolved in A and B. So that could be something like 5 times A and 1 times B. So if you try to plot V now, so if A were 4 units in this direction, I'll have to draw a really long line of 5A. So this length here would be 5 times 4, or 20 units in the east direction, and this would be 5 times A. And for B, we'll do the same thing, but we just need to multiply that by 1. So it would be the same length as our original B vector, so that would be B, and the length would be, well, 3 units, same as B. And we must add them now to get our V vector. So that would be a line joining the base to the head. So this would be our vector V. So this is another decomposition, example of decomposition. So we, through this equation, have decomposed or resolved V vector in terms of A and B. So we must go 5 units in A and 3 and 1 unit in B. So 5 units in A, or 5 times the length of A, and 1 times the length of B, and that should give of vector v. So this is what we mean by resolution of vectors, and any other vector could be resolved similarly in two vectors, say a and b. You could also have other bases. You could also have any other combination of vector. You could define v as say this vector c and this vector d. So v could also be c plus d. So this is another decomposition of v, but it is in a different basis, and the basis is defined by a and b. So that's another style, but we're still resolving the vectors. So I hope this video made sense and you understood what it means by resolution of vectors and what you mean by decomposition of vector in, say, given vectors a and b. And all the best.